I'm a big fan of Git Rebase. I gave a lightning talk at work today and I thought I might just do up a video to kind of share it more widely. So this talk is just kind of going to dive into all the cool things you can do with Git Rebase that you might not be aware of. So the first thing we want to look at is why use Git Rebase? So merge and rebase can kind of help you achieve similar things. They just work in slightly different ways. It's all around managing history and kind of merging code together and squishing it together. But the way that Rebase goes about it is slightly different. And because of the way that Rebase goes about things and what it's trying to achieve, it gives you a whole heap of like micro superpowers as well. But what we might do is just conceptually talk about what Rebase is for a second and how I kind of think about it. And then if you kind of apply that thinking to each of the small things we do, hopefully you'll start to get a really good idea of what Rebase is. So in my head, the way that I've been thinking about it is Rebase allows you to kind of rewind. So say you've got a branch and you've branched off your main branch and you've got a feature branch and you've added 2 commits to that. And what you want to do is you kind of want to remove those 2 commits. You want to put them into memory and you want to into RAM on a computer and you want to make some changes as you're going in RAM. And then when you're done, you want to persist them back to the hard drive, and that'd be like putting them back in the branch where they go. So it's all about like manipulating the branch that we've currently got. And hopefully you'll see how that kind of applies, and I'll kind of reiterate that and come back to that analogy a little bit. So what can Rebase do? So it can actually do a whole bunch of things. This is the Git Rebase interactive menu. When it pops up in the terminal, we'll see this a whole bunch in a second. And we're going to go through these, but you can pick reword, edit, squash, fix up, execute, break, drop, label, reset, merge, and reorder commits. So let's dive into the first thing, which is reordering commits. So what we've got here is I've just got this branch here that I've just created just for the sake of this talk. And what we'll do is we'll just touch a file here and we'll add it, and we'll add a commit, which is, add test.txt. Okay, so now when we check out our Git log, we can see that this is the most recent commit. But I don't want that there for whatever reason. If you're kind of trying to manipulate history, you want to kind of put that somewhere else. So what we're going to do is we're going to rewind. I'm going to rewind history. So I'm going to go Git Rebase. I want to do it in interactive mode, and I want to rewind up until this commit. And what that's going to do, like I said, just think of it as putting all of these commits in memory. And then you can kind of tell the computer to do some stuff with it, and then it'll write it back to the hard drive. And the reason that it kind of does it in, like thinking about it in memory, is that if something goes wrong, it's kind of transactional in that you can always revert back to what's on the hard drive because you haven't kind of committed it back to the hard drive yet. So anyway, what are we doing? We're rearranging some commits. All right, so I've got this add test.txt. I'm just going to shuffle this one up in the list, and I'm going to make it add here, and it's just rebase those. It's just put those back onto the hard drive. And so now we can see that that commit that I just did is actually now in the middle. It's no longer the most recent commit. And just to show that again, what I'll do is I'll actually bring it back now and make it the first commit. And there it is. As our first commit. So you can see that you're able to kind of manipulate the history of the branch using Git Rebase. Now, I can only imagine that a lot of the time when you do rearrange a commit, you're probably going to end up in some trouble. So let's have a look at what that kind of looks like. So I did a classic Git thing where I added a file and then I fixed the empty file because it was supposed to have a JSON object in it, just an empty JSON object. So if I do a git show on this commit, it's just empty. There's nothing to show. And if I do a git show on this one, this was me going, oh yeah, I meant to put an empty JSON object in there because it needs that to be valid. So what I'm going to do is I'm going to rearrange the order of these 2 commits. And as you can imagine, Git's going to freak out because it's trying to add an empty JSON object to a file that doesn't exist because that file was added in the previous commit, which I'm actually going to now push to the future. All right, so let's have a look again. We'll do Git Rebase, and we've got add, empty config, and fix. So I'm going to change the order of these. Oh, wrong way. Okay, and Git has exploded, conflicts, doesn't know what's happening, it's freaking out. I'm freaking out. I'm not used to Git rebase. I don't know what's happening, which of course brings us to aborting a rebase. So sometimes when you're doing rebases, when you're doing all sorts of things in Git, really, stuff can go horribly, horribly wrong. So being able to get out of a rebase is probably a super valuable skill. So I can tell that I'm in a rebase because I've got this rebase-i here. And I can see that, you know, something funky has happened. Now, I might be able to, if I know what I'm doing, I might be able to fix this problem. You can see it's been deleted and updated in the one commit, so it doesn't know what's happening. But rather than do that, I am actually just going to abort this. So I'm going to go git rebase -- abort. And that's taken me back to where I was. So these are now in the correct order. It's just kind of gone, oh, forget about everything that you put into memory. Just go back to what you previously had on the hard drive. So that's git abort. So super handy skill, something you should definitely know about is aborting a rebase. Okay, let's have a look at something I use a fair bit, I guess, which is rewording an old commit. So I have something you've probably done before is like git commit amend. So if the most recent commit is this add test.txt, I could reword that one with git commit -- amend. And here I can do this. I can say add whatever instead. Okay, so I was able to do that, but I'm not able to go, I've got this whip commit here. Like I want to reword this one, and I don't want to have to like reset all these and then add them all again and rename them and whatever else. Like I just want to change this, and Rebase allows us to do that. So we'll come in here, we'll go to our whip commit, and we're going to say R for reword. So I can use the shorthand. You can see here I've got R, and then I can also use reword. So you can choose whichever one you want there. They both do the same thing. So I want to reword this commit. And it's going to take me here, and I want to say add readme. Oh, I didn't want to say add readme. I don't even know what does this do? Probably should have checked what the commit does. It doesn't add the readme, it actually adds content to the readme. So we'll just for the sake of it, come in here again. We'll go and reword this one. And we'll change this to populate readme. Cool. So now we've added the readme, we've populated the readme, so you can see I was able to reword that one without having to kind of redo all this history, which is really nice. So that is rewording an old commit with git rebase. Another thing we can do, so that was us rewording the content of the commit message. But sometimes you actually want to change the code or the content of the commit itself, not the message. So I left a to-do in the README, and I'm not a big fan of committing to-dos. So if we have a look at this commit, well, to-do, add some stuff here. I need to fix that, or I want to fix that. So we'll do a rebase, and I'm going to edit. So I can do an E, again, shorthand here is E. Or edit is the longhand. So I want to edit this one, and it's just left me in a state now where I'm in the commit that I was working, that I wanted to edit. So I'm kind of, if you just think I'm kind of in it right now. So all the changes of that commit have been applied, and then it stopped right before it's continued on. And so I can now do stuff, and I can go, yeah, all populated, lated now. Whoop, can't spell it all. Here we go. Okay, so if I do a git diff, I can see that I changed that to do. So I'm going to add that. And now what I'm going to do is I'm not going to do a git commit because I'm already in the commit that this change should be in because I'm editing the commit. All I need to do now is add it. So I've added it. Oh, that's, we want a status. Yep, I've added the modified file. And so now what I do is I do git rebase -- continue. And it's taking me to, it allows me to, like, now that I've finished that commit, it just gives me a chance to change the message for reals. So this time I really did it. And there we go. So we've got populate the readme for reals. So if we show that, that to-do is no longer in there. So that was the second commit that was ever made to this branch, and I'm able to rewind back to it and do things to it. So we're currently here, and this is the first commit, and that's the second commit of this whole thing. So pretty cool. So amend a commit. So we've done that. So let's move on to squashing a commit. Okay, so how many times have you added an empty config file and followed it up with a fix empty config file? Like just following up with that, oh, maybe I fixed it this time, think I fixed it. So I want to look smarter than I am and make it seem like I didn't really have to fix this a million times. So what I'm going to do is I'm going to squash these two commits into one, and that's going to combine the two. So let's do that. So git rebase interactive. So fix empty config. I'm going to squash this, S for shorthand. And what that means is that commit gets pushed up into this commit. And let's do that. And it's going to do this. And now it's dropping us in here to be able to edit the commit message because they've both got different commit messages. But potentially the content here is valuable. But in this case, it isn't. So I just comment this out and cool. And so now when I see add empty config file, what do you know? I added the file and I added the empty JSON object all in one go. And I didn't even have to follow up with a fixed commit. So that is squashing a commit. So it's being able to combine two different commits. Fixing up a commit. This is the same as squashing a commit, but it's a little bit more succinct. So essentially what you're saying is squash this commit. Actually, let's go into the example because this is probably a bit easy to look at. Okay, so actually, I'll just reset back to main just so I get those commits back. So now I've got these two commits back that I previously had because I've got my main branch has everything set up like I needed for this talk. So I've just reset back to that state. So I've got these two commits, again, adding the empty config file and then fixing the empty config file, and I want those to be the one. So we'll do a rebase. So what I'll do is I'll do a fix up, and what this should do is this will squish it up, but it'll only keep add empty config file. It won't take me to the place where I can write a commit message. Yep, didn't bother me about writing a commit message. It just took the commit message that already existed in the commit that was being kind of fixed into, maybe the terminology is, I don't know. And alternatively, you can use -C, and what that does is kind of the opposite. So actually, we'll reset again, rebase. So if I do this -C, what I'm saying is squish this commit up into this commit, but actually this is the commit message I want to keep. I don't want that one. So it's just, again, just another shorthand, and you can see fixed empty config file is now the commit message, which, you know, isn't really what we would want in this case, but just to show you that point. And that is fix up a commit. Execute arbitrary commands between commits. So this blew my mind a little bit. And I didn't know about this one before I kind of started putting this talk together. So this is really interesting. So this allows you to, just as it says, execute arbitrary commands between commits. So I was trying to think of a reason why you might use this. I can't think of any really good one, except for maybe you've like built out a PHP app and then, you know, the PHP fig comes along and goes, hey, coding standard. And you want all your code to have adhered to this coding standard throughout time. So what you could do, if you wanted a really terrible weekend, is you could rebase right back to the beginning of time, and in between every single commit, you could run PHP CS fixer or something to kind of adhere to the PSR. And that way, what it'll do is it'll replay each commit, then it'll run PHP CS fixer, and if there's any changes to the code, it'll stop and let you know. You can then add those changes to your commit. And if you kind of keep going through that process, by the end of it, you know, if you've had a year worth of code, every single one of those commits will now adhere to the PSR2, which they previously didn't, which is kind of cool. I'm sure it's probably mostly for automation, but I'll just show you it in action. I'd love to know if anyone's done anything cool with this. because yeah, I can't think of anything amazingly awesome, but I'm sure there's cool stuff to do. So all I'm going to do is I'm just going to come in here and just be like execute hello into the README. I know it's boring, but I don't know what else to do. So it's just going to replay all the commits, and randomly in the middle, it's just going to echo hello into the README. And yep, we've got an unstaged. So if I diff this, yep, it found a change. So I'll add git rebase -- continue. Oh, maybe I need to read it. Oh, okay, this is... Oh, okay, sweet. So if the changes are meant to be squashed into the previous commit, run that. So I'm just going to run that. And there we go. So, you know, it's got that in there. Again, not sure what you would use that for, but it's there if you ever needed to do something fun with it. Break between commits. All right, so what we'll do is we'll reset and we'll do a rebase again. Git rebase -i. Abort. I've gotten myself into some kind of craziness and I don't know what's happening. So I'm just going to rebase abort. I don't think I did the added this correctly to the commit. Like I said, I'm not really familiar with this and kind of how that works, but yeah, I'm sure you could work out something cool to do and do it better than I can. Okay, so where are we now? Okay, so git rebase interactive. Okay, what we want to do is maybe we're doing this right, like what our example before, adding PHP CS fixer, but we want to make sure that we can like have safe places to stop or something, so we can go and have a snooze or go grab some coffee. So we can pause a rebase by adding a break between commits. So I'm just going to write break. And what this is going to do is it's going to replay this commit, and then it's going to stop. And then it's going to replay this commit, and then we'll be done. So there we go. We stopped at. We can see we've stopped, but I'm still in a rebase, but there's no errors or anything. It's just stopped. Again, maybe if you're doing like a really massive rebase, this would be really handy. Git rebase -- continue. And now we're just back to where we were. It's just replayed all the commits. So yeah, that's a way to kind of break between commits if you wanted to do that. Dropping commits. Yes. All right. So what do I want to do? I don't want this git ignore. We added a git ignore and we don't really need it. So what do we got? .git ignore. Oh, classic DS store. Yeah, we just don't need this git ignore in this. So what we're going to do is git rebase interactive. And we're going to use D to drop it. And what that'll do is it'll replay this commit, and then it's just not going to add this commit. So any changes or code or anything that's been added is just going to disappear, and then it's going to keep on keeping on. So I'll do that, and you can see that that commit has just disappeared. So we no longer have a .git config, git ignore, sorry, in the root directory here. It's just gone. So that's how you can kind of just drop commits randomly, if that's useful. Label. Okay, I have no freaking idea what label does. Something along the lines of doing multi-branch rebases or something. I have literally no idea what label does. Maybe someone else can tell me what label does and like a good use case for it, because yeah, I've just never come up against a need for it. Maybe it's awesome and I just haven't worked that out yet. Git rebase merge. I also have no freaking idea what this is. I think what this is doing is it allows you to do a rebase, but then it also creates a merge commit. So you kind of get the both worlds of doing a merge with a merge commit, but you get the linear history. So you can tell when kind of features have been merged in. Again, haven't used it. If someone wants to chime in and tell me where git rebase merge is good, please do. Okay, merge versus rebase for history management. So let's have a little bit of a look at how this works with history. Okay, so we've got these kind of represent commits here. This is a Git history tree. I don't even know if that's what it's called. That's what I'm calling it though. So we've got 1 commit, 2 commit. This is kind of our main, all these purples. And then these oranges over here, these are branches that have been forked off. And the arrows come from a commit and they tell you kind of where they've come from. So this one's come from here, this one comes from here, come from here, come from here. Okay, so this is our template for what we're going to use to look at how things are different between a merge and a rebase. So let's come down here and we'll see what does a merge look like. Okay, so we want to merge these things. So one thing to note here is that this actually has, F has a linear history all the way through to A. It is being visualized as being down here lower, but we can see by the arrows, you know, that there is just a linear history there. It just goes, there's a straight line all the way through. And so what can happen when that is the case and we do a git merge, what it does is a fast forward merge, which just basically means that these kind of just pop up here and this pops up here. Oh, I should also specify that I'm not a Git expert. Hopefully a lot of this information is somewhat accurate, but this is kind of my understanding of things. So feel free to tell me I'm wrong with any of this. With a fast forward merge, these essentially just kind of pop up here and everything's happy. Nothing really fancy happens with a fast forward merge because there's a linear history. But now something's happening where G doesn't contain the contents of D and F. It doesn't have these commits, but we want to add it. We want that branch to kind of appear over here. H. So what you do is a git merge, and it will do a merge commit when you don't have a linear history, because this G does not have a linear history to F. It has a linear history to C, but that's no longer where we're trying to get to. We're trying to get to F. So what Git does is a merge commit here, where it actually creates a new commit with kind of 2 pointers, one to the previous head of main and one to the top of our branch here. And this allows it to, any conflicts or anything like that all kind of get merged into this merge commit here, I believe. And so now you can see we've kind of got a bit of a funky history here where this was just 2, but you can imagine if there was another branch and another branch and another branch, this kind of keeps on going on and on and on and on. And so your history graph can start to look a little bit funky to kind of know where things are coming from and how they work. But this is what a merge looks like. This here is exactly what a merge looks like once there's been a bit of history in between. And you didn't create this commit. This commit was created by Git. So you've now got commits in your branch that kind of aren't representative of what you did, but rather what Git did. So let's have a look at what Rebase actually looks like. So starting from that same template, Rebase does, the goal is the same. The goal for both of these things is the same, is to kind of essentially get to H, where the code from F and the code from G are both in the same commit here, or like visible in the same branch, I should say. Okay, so like we did before, we're going to do a merge on F, and it's going to do a fast forward because we've got a linear history, just like we did before. F, D, C, we've just got that linear history. So we'll bring those in, we'll paint those a nice color, and everyone's happy. Now, instead of doing a merge commit, what we're going to do is we're going to tell our branch, we're going to be on this branch, and we're going to rebase it against main. And remember what happens when we rebase? It kind of takes all the commits you've done and puts them into memory. So you can imagine it kind of shoves them off into a box. It then we're rebasing against main, so it replays all of main up until F and goes, cool, that's now our new starting point. Now what I'm going to do is I'm going to bring these commits back, and I'm going to have them point to F. So now we do have a linear history again. I am visualizing it up here because it is still in a branch, but there is now a linear history that we've got. Rebase has allowed us to achieve that linear history. So now when we do a merge on this branch, we have a linear history throughout all of time. Whereas merges and more and more and more of these will mean there'll be more kind of spikes. And if you branched off this and branched off that, it kind of keeps going. Whereas this kind of creates a linear history for you. Now, merge commits aren't necessarily bad. I'm not saying that they're bad. I'm just trying to show you the tools that are available and how they work. So merge commits can actually be very useful in that they tell you when a branch was merged. So if you're working on a big new feature, it might be handy to just have a commit to be like, hey, this feature was merged. And that's what a merge commit almost kind of signifies for you. Whereas this is kind of more of a pure history of like what was done by the developer and in what order. And I think for me, Git rebase, rebasing and then merging kind of fits my mental model of what I'm doing when I'm in GitHub and I kind of hit merge commit. My brain is kind of showing me like, it's kind of thinking, add these commits that I've added to the end of the list, not kind of mush them in. And another thing that can happen as well is if you're running CI, so if you've got this branch here and you run your CI on this, so you're running your tests, your static analysis, your linting, whatever it is, the problem here is that G doesn't contain the latest changes in main. So there could be some code in F that when combined with G actually makes your tests fail. Maybe F, dropped a database table that G is still trying to access. Well, G will still pass and F will pass its tests, but H will fail once you kind of merge those in because it doesn't contain the changes here. Whereas when you rebase before merging, it means that, when these were up here in their branch, they've still got all the commits throughout time. Oh, they should be orange because there's a linear history. So, G does contain the dropped database, so the tests will fail here rather than failing here when we merge into our main. So hopefully, there's a lot of these kind of graphics online. Hopefully that was a good little walkthrough of kind of how that works and what the kind of differences are, not just kind of the static images that we kind of see everywhere. All right, so a couple of notes here to go through. So it ensures that we develop a feature branch at the time of merge. The develop and the feature branch at the time of merge are exactly the same, which is what we just talked about. Otherwise, technically, the tests and linting that pass may not pass when they get merged into develop. Develop being the branch, I should have used main here to have consistent wording. So have you ever done a merge from, say you've got main and you kind of got a feature branch and you merge from main to your feature branch and maybe you had like two really small clean commits in your feature branch, and then after you like merge to get the latest changes into your feature branch, all of a sudden on GitHub there's like 1 million commits. This kind of stops that, right? It just makes sure that the only commits that are kind of changed in your branch are the commits that you care about at the moment in your branch. Fix conflicts without new commits, and it makes them much easier to see. All right, like I said before, this kind of captures all the merge commits. Like when you do a merge and there's conflicts and you've got to change them, you get dumped all the conflicts in one go. And when you fix them, they get mushed into this merge commit here. So let's take a look at that. Like let's do make the rebase example. Okay, so we'll do a git init. And then we will do a config.json. Lovely. And we'll git commit. Oh, did we add it? Yeah, git commit message. And we'll add config. Okay, so what we'll do now is we'll do a branch and checkout. We'll do branch 1. And in this branch, so what I'm going to do is I'm going to create 2 branches, branch 1 and branch 2, and I'm going to bounce between the 2. So in branch 1, I'm going to add a new setting and then do a commit. Then in branch 2, I'll add a new setting, do a commit, come back to branch 1, add another setting, do a commit, go back to branch 2, add a setting. And all these settings will conflict with each other. And then what we'll do is we'll do a merge and we'll see what that looks like. And then we'll do a rebase and see what that looks like. And this is, a very, very small example, but hopefully you'll see how it applies if you kind of run into these things in the future. Okay, so we'll go into our config and we'll do feature 1. Cool. And we'll add that. Good. Commit message, and we'll do feature 1. Okay, cool. So now I'm going to check out. Oh, my fingers are not working, excuse me. We'll do branch checkout branch 2. Okay, so this shall be just an empty config, and we're going to do feature 2, and we'll add that. Feature 2, get commit message, and this is feature 2. Cool. We'll come back to branch 1, and we'll add feature 3. Feature 3. This is feature 3. Sorry, this bit's a little bit boring. I'll just check out the last branch. But we'll have this set up after this one, which is 4. So feature 4. Cool. Okay. So what we've got here on this branch is we've got the adding of the config, which is the initial commit we kind of branched from. And then we've got feature 2 and feature 4. Come over to branch 1. You'll see we've got add commit config, and then we've got feature 1 and feature 3. Okay, so what I'm going to do now is I'm going to go into our main, and I am going to merge in branch 1. Now, remember our drawing that we had before. Branch 1 is a linear history. Yes, it is a branch, but there haven't been any new changes on our main. So branch 1 currently has a linear history. So it's going to do a fast forward commit, which means it just applies the commits, doesn't do a merge commit at all. So we will do merge branch 1, and you can see, yep, did a fast forward. So if I do git L, linear history, and we've added F1 and F3. Now, however, branch 2 does not have a linear history. Branch 2 has a linear history to this commit, but it doesn't to these commits. And it conflicts with these commits as well. So let's merge it on branch 2 and see what happens. Okay, we've hit some conflicts, which we expected. I can't get out of that. So let's see what's happened. Okay, what you'll notice is that it has brought in our head. Yep, we want that. And then it's also brought in our 2 commits. So it's brought in both commits at once. So we're fixing all conflicts through all the commits that we had in our feature branch. So if there were 100 different conflicts over 100 different commits in this one file, that'd all be here, right here for us to fix. And so we finish that. Yep. And then we do a merge -- continue. What's happening? Oh, I didn't add it. So we'll try that again. Okay, now again, this is adding a commit that I didn't name, merge branch 2. So this is the merge commit that is being created. So I'm not going to change the name of that. And now if we look at history, you can see our graph is starting to get a little bit funky. And this is what we saw in our FigJam file earlier with those examples of how these two are still out here. And these graphs can get quite crazy depending on your team and how they work. And what's more is this is a merge commit that wasn't something that we created. So let's have a look at what this even has in it. Git show. You can see it actually contains content as well. So it's kind of like, I don't know. I find it a little bit weird. I'm sure it has great uses, but it just kind of feels a bit weird. So that's fixing the conflicts with merge. But let's see what it looks like to do it with Rebase. What is the difference? we're still going to hit the same conflicts. It just goes about it in a different way. Because remember, rebase is all about rewinding and then applying each commit one after the other as needed. Whereas merge is just kind of like, it just tips the bucket over and is just like, all the commits go all the time, all in one big go. It's just a big rubber band ball of commits. Okay, so what we'll do is we'll check out branch 1 and well, git check out branch 1. I can't spell check out branch 1. Cool, and we're going to do a rebase against main, which really isn't going to do anything because we've got a linear history already, so it just rewinds to our shared history point and then kind of replays my commits, which again, do nothing. Cool, so we'll check out main and we will merge branch 1 and we've got our linear history. So now what we'll do is we'll check out branch 2 and I'm going to do a git rebase main. And so what this is going to do is, actually before I do this, let's have a look at the log. So what it's going to do is it's going to take these two kind of off the pile, put those into memory. Then it's going to go, okay, this is our shared commit. So go back to there. Now add all of main's commits here. So it'll be like, this one, and then it'll be feature 1 and then feature 3. And then it's going to try and play my new commits in this branch on top of those things to kind of put them at the very end of main. So we'll do rebase main. And yes, we hit a conflict just as we thought we would. But things are a little bit different here in this conflict in that this is what came from main, which is expected. Right, feature 1 and feature 3. On our branch here, we added feature 2 and feature 3 in different commits. When we did our merge, feature 2 and feature 4 were both here. I don't know if you remember, but this used to be, this was feature 4, like this. But in Rebase, it's doing them one by one. So it kind of gives you a greater like laser precision kind of thing to be able to make these fixes. And so when I fix that, I will add that and I will do rebase continue. And so that change that I made is not being applied to a git commit like it did with like a merge commit when I did the merge into main. Oh my gosh, I just repeated so many words. Instead, what it's doing is it's adding those fixes to the commit, like the conflict fixes to the commits where those conflicts were created in a linear history. I don't know if that really was very clear. So that was F2. Yep, so that's cool. So then if we come here, you can see we've got another conflict because we added 4. So we're going to come down here now and, oh, I deleted 2 as well, which I didn't mean to. Lovely. We'll add that. Git rebase -- continue. Okay, so now, now you'll see that we've actually got a linear history and we've got everything from main. The main's up to here, and then we've got our commits here. And I just want to show you what I'm talking about with like those fixes aren't in their own, those conflict fixes aren't in their own commit. They're actually in the commit that I want them to be, in the one where I introduce the change. So same with this one here. It's fixing them as we go, which is, I think, sick. So we'll check out main and we'll git merge branch 2. And look, it did a fast forward because we had a linear history, and now we've got a linear history with our branches. But as you can also see, like, I mean, if we delete those branches, I'm assuming git branch delete that, git L, and if I delete branch 2 as well, git branch delete branch 2, you can see that we've lost the ability to know because previously it said, branch 2 here, and up here it said branch 1. As I remove those, or if you don't have those branches yourself, you can't see when I merged branch 1 and when I merged branch 2. Sure, you can see, this commit was done and then this one, and this one, and this one. But you do lose that information. So it's a bit of a trade-off as to what exactly you're trying to achieve and what these tools do. So as you can see, merge and rebase do similar things, just in different ways. Are merge commits good? Hopefully we've kind of talked about that and about why merge commits are actually good and useful if that's what you want, to be able to track those big features being merged into your repository. And yeah, I think I've talked to this already, but the way that I think about merging is like I'm always adding to the end of the stack, the end of the history. With Rebase, that is the case, but with merge, it isn't always the case. Something I want to mention as well is that you want to make sure that you're only doing git rebase from your private branches. You don't want to do it on main itself because you'll absolutely ruin history. So you want to make sure, you're just doing it in your branches. And then if you've kind of got your own branch that you're kind of monitoring yourself and you've got to do a force push, just make sure that you're doing like a force push with lease. Which is a config option to make sure that you're not overriding any commits that you currently don't have locally, just in case someone else has pushed to your branch as well. But yeah, just remember you're redoing history, so just be careful. Make sure you know what you're doing. Cool. That's really everything about Git Rebase. Here's a few little snippets of some bonus kind of aliases, shortcuts, and configs that I just thought would be cool. I can't remember who I learned this from. Someone in the Laravel community. I think it might have possibly been Jess Archer that I first saw doing this, but this is having a global git ignore and ignoring a scratch.markdown. And so what I think I've got, if I come back here and go into Rebase, I think if I search globally, I've got this scratch.md. And so what I can do is basically do whatever I want with this. And it's gonna just be my like markdown place where I can make my notes and do whatever I want. But it never gets committed. It's kind of hidden from Git. So if I do a git s, it doesn't show up when I add changes. It's kind of my like local project to-do list in a way where I can kind of make notes and come back to it. So I ignore that globally so I can have one in every single project. So that's a really handy thing, I reckon. Git checkout dash. So you might be familiar with this as well. So if I go, where am I? So I'm currently in users tim code rebase. So I'm just going to go to / users, just change directory there. And what you can do is you can do cd and then a hyphen, and it'll take you back to where you previously were. Now, I just deleted all those branches, didn't I? Oh yeah, I've got main as well. Okay, so if I go git checkout main, and I want to get back to the branch that I was just in, I can do git checkout dash, and it'll just kind of switch me back. And again, I can do it again, and it'll take without a backslash, and it'll kind of switch between the two branches. Just a nice little shortcut to be able to switch between the two branches. Git config push.fault. So if I come to my .files and go to my git config and push, so if you have a git config in your kind of home directory, if you add, don't delete it, push and default current, what this does is make it that when you do a git branch locally and then you do git push, this basically tells Git to like assign the current. If you've ever had that whole like set upstream thing when you've just created a branch, this will help you get rid of that like 99% of the time. And it'll mean that you'll never have to be like, set upstream to, the branch that I'm currently in. This just does it by default. This could even, I don't know if this even is the default now, but super handy to have. Like I said, 99% of the time this will work. Sometimes when you do a pull or a fetch, things can go a little bit weird. And this is a sick little, I've got a link to all this as well. This is a nice little alias. So I can just call git set upstream, and it'll do essentially this, but in the branch that already exists, that kind of is already at the origin. And so, just kind of does the set upstream to like the branch I'm in. Because, 100% of the time I want to say like the branch that I'm in, whatever it is called is what it is called on origin. I'm not like renaming branches locally. I'm just not that cool. This is a great little tool that was originally built by JMac in the Laravel community. So this is git open. So if I just type git open, it'll just take me to the hosting provider where my .file, wherever that repo is. So if I come back and I go to cd, what is it called? Rebase, and I go git open, it again pops me out to my Rebase. So it supports, I'm pretty sure it supports like all the big providers, so GitLab, I assume Bitbucket, things like that. So that is pretty sick. I use that all the time to like get to the repository online. Super handy. Thank you, JMac. Git flow. We use Git flow at work, so this was kind of more for my work peeps. But this is just a plugin for Git to kind of help you easily create feature branches and stuff. It's just a little helper. Git Delta, which kind of makes everything look pretty in my Git stuff. So if I do a show, I don't know if this was on this branch. Yep, no. Yeah, this is a terrible branch to even show this in, but it just makes all the Git stuff on the terminal look really nice. So Git Delta is really sick. So you can check out my Git config in my .files for a bunch of other stuff. What else is there? Anything? So lots of colors and stuff, because you've got to have pretty Git stuff. I stole this from someone in the Laravel community as well, so thank you for whoever kind of gave me that to forget local branches. Git L for like a really nice log. I think I stole this from Paul Irish to have a nice log, because you might be familiar with Git log, which is this, but I don't really need, like, this is like a beautiful log. That's all I really need to see. Yeah, they're probably the exciting things in there, so we'll just move on, shall we? Okay. Another thing that I remember hearing in the Laravel community that I thought was a really interesting idea. I can't remember who said this, so I'm sorry I can't give you a shout out, but the idea of writing your commit message before you've actually written the code. So just like you were like TDD, right? Like you write your test before you write your code. This is essentially trying to keep you on task, where you write the commit message first, and it's kind of like the promise to yourself, like, this is the thing I'm going to focus on. I am going to like build the endpoint to do the such and such. And so you could write an empty commit message. You might do git commit allow empty, and you could add whatever you want in here. So, build the thing. And we've got an empty commit here, which I can push and do all sorts of things with. And then I can use Rebase, like we've seen, to kind of edit that commit and add the changes that I've already got locally into that commit to kind of hold yourself to that. So that's kind of maybe a little productivity boost that people might like. Might not jive with everyone. And that is kind of everything with Git Rebase that I wanted to share. So hopefully this has been cool. Hopefully you enjoyed kind of some of the bits and pieces and learned some things. Love to hear any questions, any thoughts, any feedback, any corrections, anything to do with Git label or Git merge, or anything sick that you've done with Git execute, where you can like execute those commands in between. Would love to hear it. And if you kind of want to continue on your journey of like new Git stuff, check out Git Bisect. Really, really interesting thing where you can kind of find there's like a certain change that you're looking for in history, and you don't know where it was in your whole repository. Like, where did someone add this database column? Like, I need to kind of see this, or something like that. You can use Git Bisect to track down exactly where a change was made. It's really cool. So check that out. All right, enjoy.